Imagine a world where the very foundations of biology as we know it are shaken to the core. A world where the impossibility of yesterday becomes the reality of today. Welcome to All Sci Fi What If, where we explore the uncharted territories of scientific possibility. Today, we're diving into a question that could redefine our understanding of life itself. What if we discovered non-carbon life? Picture this. It's a typical day at NASA's Jet Propulsion Laboratory. Scientists are huddled around screens analyzing data from the latest Mars rover mission. Suddenly, a gasp echoes through the room. The instruments have detected something unusual, something that defies everything we thought we knew about life. As the news spreads like wildfire through the scientific community, one thing becomes clear. We are no longer alone in the universe, in life as we know it. Well, we don't know it at all. But before we dive into the implications of this earth-shattering discovery, let's take a step back and consider why this finding is so revolutionary. To understand that, we need to grasp the basics of carbon-based life, the only form of life we've known until now. Carbon is the fourth most abundant element in the universe. It is the backbone of all life on Earth. Its unique properties allow it to form complex, stable molecules that can store and transfer information, a crucial requirement for life. It can form up to 4 stable bonds with other atoms, creating a vast array of possible molecular structures. This versatility is why carbon is often called the element of life. From the simplest of bacteria to the most complex mammals, all known life forms use carbon as their primary building block. DNA, proteins, fats, carbohydrates, all of these essential components of life are carbon-based. It's no wonder that our search for extraterrestrial life has focused on finding conditions suitable for carbon-based organisms. But what if we've been looking at the universe through carbon-tinted glasses? What if life can exist based on entirely different chemical foundations? Enter silicon, carbon's lesser-known cousin on the periodic table. For decades, scientists have speculated about the possibility of silicon-based life. Like carbon, silicon can form up to 4 stable bonds, potentially creating complex molecules. It's also abundant in the universe, making up about 28% of the Earth's crust. However, silicon has some significant drawbacks compared to carbon. Silicon-based molecules are generally larger and more unstable than their carbon counterparts. They also don't form double bonds as readily as carbon, limiting the diversity of possible molecules. Despite these challenges, some scientists argue that under the right conditions, perhaps on a much colder world with a silicon-rich environment, silicon-based life could theoretically evolve. But our hypothetical discovery goes beyond silicon. Imagine life based on boron, nitrogen, or even metal compounds. Each of these alternatives would require radically different environmental conditions and would likely result in life forms utterly alien to our understanding. Now, let's return to our scenario. The discovery of non-carbon life on Mars. As news of the findings spreads, the implications begin to sink in. This isn't just a new species or even a new kingdom of life. It's an entirely new biochemistry, a second genesis. The first question on everyone's mind: how did it evolve? Did it originate on Mars, or was it transported there from somewhere else in the cosmos? If it did evolve on Mars, what does this tell us about the conditions necessary for life to emerge? The red planet suddenly becomes the most valuable real estate in the solar system, with every space agency and research institution clamoring for a piece of the action. but the implications stretch far beyond Mars. If life can evolve based on different chemical foundations, the number of potentially habitable worlds in the universe skyrockets. Planets and moons, once thought too cold, too hot, too alien to support life, are suddenly back on the table. The search for extraterrestrial intelligence gains new urgency and direction. Let's zoom in on the practical challenges this discovery would present. How do we even study life forms with completely different alien biochemistry? Our current tools and techniques are designed for carbon-based life. We'd need to develop new methods for everything from detection to analysis. Imagine trying to sequence the genetic material of an organism that doesn't even use DNA or RNA. How would we decode its information storage systems? How would it replicate? The answers to these questions could revolutionize our understanding of information theory and even inspire new approaches to computing and data storage. Then, there's the question of communication. If we eventually discover non-intelligent carbon life, how would we interact with beings whose thought processes might be fundamentally different from our own? It's not just a matter of language. Their entire perception of reality could be alien to us. But perhaps the most profound impact of discovering non-carbon life would be philosophical. For centuries, we grappled with the question of what makes something alive. We've drawn lines between living and non-living things, between consciousness and unconsciousness. The discovery of radically different life forms would force us to redraw these lines, or perhaps erase them entirely. Would a silicon-based organism have rights? Would we consider it murder to deactivate a self-replicating machine intelligence? As we expand our definition of life, we may need to expand our ethical frameworks as well. As we stand on the brink of this hypothetical discovery, one thing becomes clear: our understanding of life, of the universe, and our place within it is far from complete. The discovery of non-carbon life would be a humbling reminder of how much we have yet to learn. It would also be an inspiring call to action, a reminder that the universe is stranger and more wonderful than we can imagine, and that there's still great discoveries waiting to be made. Who knows? Perhaps somewhere out there, a silicon-based intelligence is asking the same question about us. As we conclude this journey into the realm of possibility, I want to leave you with a thought. The quest to understand life in all its forms is perhaps the greatest adventure humanity has ever undertaken. Whether carbon-based or not, each new discovery brings us closer to answering the fundamental questions of existence. What is life? How did it begin? And are we alone in the universe? The answers may be out there, waiting for us to find them. All we need to do is keep looking, keep questioning, and keep imagining the impossible. This has been All Sci-Fi What If. Until next time, keep your eyes on the stars and your mind open to the endless possibilities of our universe.